In this video, I'm going to solve some engineering problems, complex numbers, and its application. So we have our first problem, is to find the magnitude of the resultant force given in this picture. So let's put it in a graph. So here, and we have the 60k newtons of 60 degrees. So say this is your 60. So this is your 60k angle 60 degrees newton. Then you have your 45 degrees. So from your base on your base here, this is our reference. So let's put here, and this will be 135. So in this point, we have 2k angle of 135 degrees. So the formula for the magnitude for the resultant force is just equal to absolute value of F2 angle degree 2 plus F1 angle degree 1, and use the calculator, and we just put absolute value of your force 2, let's say 6,000 angle 60 plus 2,135, and this will give you your force, which is 6,797.92 Newton. To find the distance between the port to the boat, so let's make the graph. It says here that we have north 47 degrees to the east. So this is your east, this is your north. So 47 degrees. Let's say this is your 47 degrees. And this is for 3.5 hours. Then it says it made the turn southeast 43 degrees. So let's make another imaginary graph, and let's say this is your 43 degrees south of east, and it says here that we have to find the distance. So I just rewrite this here. So let's say this is your 30.5 hours, and this is the 4 hours, and we're looking for the distance here. So we all know this is 90 degrees because 43 plus 47 is just 90, and the formula for this, for the distance, is just the absolute value of your z2 minus z1. And oh, I forgot that we have 22 knots, so you have to multiply this to your hours. So in the calculator, we have the absolute value of 3.5 times 22 angle of 0 minus your 4 hours times 22 angle of your 90 degrees. So we have here your distance, which is 116.93. Okay, and this is the last problem for the applications of our complex numbers. This time is our AC circuit from our circuits 1 and 2. Okay, so first we will find the V1 and V2 in polar mode, which is having angles. So we can see here that this is a supernode. So I just put here V1, V2 minus V1 is equal to the 20 angle 60 degrees voltage, and we let all the current. So this is your A1, this is your I1, your I2, this is your I3, I4. So we can say that I1 is equal to I2 plus I3 plus I4. From there, we will use our KCL. So we have 50 angle 0 degrees minus V1 over 4 equal to V1 over J4 plus V2 over J negative J plus V2 all over J. From there, we simplified this further, and we have 15 over 4 degrees 0, or we can just took this out because it's still the same thing, minus V1 over 4. So we transferred all of this to the other side, and we have here negative J over 4 V1 minus I or J, because negative J, 1 over negative J is just I or J V2, and we have negative 1 over 6 V2 equal to 0. From here, I will move the one that hasn't have a V1 V2 to the other side, and here I will simplify this or transform this into a polar form. So the polar form for this, let me put a box of this one, is square root of 2 over 4 angle of negative 135 V1, and this one, this will be minus square root of 37 over 6 angle negative 99.46 V2 equal to negative 15 over 4. This is be our equation 1, and our equation 2 is our supernode of negative V1 plus V2 equals to 20 degrees 60. So from there, we will use the Kramer rule or Kramer's rule. So let's put here square root of 2 4 angle of negative 135 to negative 1, and here we have square root of 37 all over 6 angle of negative 99.46 1 times your V1 over V2 equal to your, let's move it here. Okay, so you have your negative 15 over 4 and your 0 point angle of 60 degrees. Okay, now we're going to find the main data first, or beta. May use a calculator. So first, the main data. So we have here the square root of 2 over 4 angle of negative 135 minus, or excuse me, times 1, so we just leave it this way, minus negative 1, so it's plus, times your here. So I got square root of 37 all over 6 angle of negative 99.46 equal to, and we get here 1.32 angle of negative 108.43. Then your next beta sub 1, this one will be here. So we got, let me refresh, so it's negative 15 over 4 times your 1, then minus your 20 angle of 60 times your this one. So you have the square root of 37 over 6, and we have shift angle to negative 99.46. And we get here 23.29 angle of 146.41 degrees. And our last data 2. So here we will use this and this one. So we have here your square root of 2 over 4 angle of negative 135 times your 20 angle 60 minus negative 1, so it's plus your negative 15. So this will be negative 15 over 4. Syntax error, so let me check again. So minus, and our last number, our last data is 7.09 angle of negative 105.70 degrees. So in order to find V1, it's just your data 1 over your main. So we get here your data 1, so 23.29 all over 1.32, and I forgot the angle. So angle of 146.41. This one here is negative 0.8.43. The answer here is 17.64 angle of negative 105.16 degrees. Your V2 is also the data 2 over your main data. So we have here, let me refresh, 7.09 angle of negative 105.70 all over 1.32 angle of negative 108.43. And our V2 is 5.37 angle of 2.73. So these are my final answers. In today's topic, I learned that it's very difficult because it's now more applications, more physics, the resultant forces, the velocity, the distance between 2 points, the cosine law, and now we have the AC circuits in our electronics or circuits 1 and 2. But I can manage it, and I hope that what I solve is the right answer. Thank you so much for watching, and see you in the next video.